This video will begin our discussion of coordinates in space. You guys have done an assignment for me to begin this discussion. This is a bit of a review. We have three-dimensional coordinate system. This is the world we live in. That we have an XY, right? That's our two-dimensional field, and then we throw a third axis in it that comes out of the XY plane. Or if you can think about it the way we've been writing it, having X and Y like this, Z would be coming out at you or into the paper, both out you and into the paper, giving us a three-dimensional system. How we're going to think about it is we have X, Y, Z, and we're going to use octants. Okay, so it creates octants. How I like to think about this is we have our normal octants, right? Octants being 1, 2, 3, and 4. Now, let me scoot this over. What's going to go directly under this to create, that's like 4 rooms almost in 3 space. We have the plane itself, and then think about coming up out of the screen or out of the screen at you, how you're looking at this. I have an iPad on a table. So I have 1, 2, 3, 4, and then this is 5, 6, 7, and 8. So it's like right underneath, but it's like a 8-room, infinite room size-wise, but 8 rooms stacked on top of each other, where this goes underneath the one to the left to create 4 rooms. I think I posted a video in the motivation assignment to kind of give you a more somebody going through it with a computer animator program, much more advanced than I am with technology. So take a look at that. That will help you understand the different octants and understanding that there are 8 rooms and where they're at. Now, we have to create this 3-dimensional system in 2D to write. What we're going to use is a right-handed system. So if you take a look there on the left, the way we're going to write this is, and you can see this up here, the X is like almost coming out at us, the Y is like that, and Z goes up and down. That portrays a 3-dimensional system to us in 2D. There's also a left-handed system with Y being in that direction. X, I've seen it flipped where Y is up. I've seen it in all directions. It really just depends on the curriculum you're looking at. What I mean, textbooks, whatever professor, if you're watching anybody online, they are going to probably use the system that was shown to them. But they're all equivalent. So if you look up a solution to a homework problem or something like that, and you're just trying to get help with it, and know that the Y may be sticking out, you still can do this. You're just going to have to change the way you think about it. Okay, so a lot of the formulas when we're going to be that we're going to be doing this semester is extending a lot of algebra and calculus concepts to 3 space. The great thing about a lot of these extensions is that they're purely that. The formulas are nice and pretty, and like what you want to happen with the formula, adding a third component happens. So for instance, the distance formula. I'm not going to go through how to come up with this. They gave you a picture here. This would be a great thing for you to go through and actually try to figure out how did they come up with this formula. It's not required. I won't ask you to do that. But notice that if I cover up, let me just mark it out. If I mark that out, that is just the distance formula in 2 space. So to get 3 space, we just add on our third component. Now, you may be thinking in your head, what if we were to add a 4th component? Would that be 4 dimensions? By our logic here, I guess. I don't like to say that, but we're going to do a lot of things in this semester that's going to be dealing with 3 space, being 3 dimensions, but we can extend it to 4 and 5 and 6, and there's all those dimensions. Even though we can't figure out what it looks like in mathematics, we're able to talk about them in a mathematical sense. It's no cool like discovery of what it looks like and a look into it. It's just more of how numbers act in those systems. Okay. So let's do some formulas for this. The distance between those 2 points. So the distance formula, I recommend when you're learning a new formula that you write it down every time you use it, and that's how I memorize. So x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. There's my formula. I write it every time I do a problem. That way I don't ever have to do the writing it 50 times to memorize it. All right, so the distance is, right, 1, I'll write them in, 1 minus 3 squared plus 0 minus negative 4. Be careful with that, as always. And then negative 4 minus 7 squared. So that gets me a distance of, okay, so that is a negative 2, so it's 4. That one is, my 4s are weird, sorry. 4 there, squared is 16. And then I got negative 4 and negative 7 make a negative 11. Squared is 121. So that's going to be the square root of 141. We're going to leave it alone. That is the distance. We could get a decimal if we wanted, but I like exact instead of rounding. Okay, we have dealt with in the past, I hope you have seen this, the formula for a circle. I'm going to write it down for you so you'll have it. If you don't know it, because we're going to use it a lot. Definition of a circle is x squared plus y squared equals r squared. Where r is the radius. We can also move these around. We could do x minus x naught. They usually put an h there in your algebra curriculums. But we'll just let that be x naught, y naught is the center. So if we had a center that wasn't 0, 0, we'd use the bottom equations. Now this extends straight to a sphere in 3 dimensions. Notice that we just add this third component, and when we add the third component, we get a sphere instead of a circle. There's a picture of a sphere off to the side. You're gonna do a whole lot of sketching for me. You're gonna do some. You'll see how I go about it. But drawing a 3D, I'm never gonna grade you on your art. I'll be looking for other things if I have you sketch. Right. Next, the midpoint formula. It's probably been a while since you've seen this. If I cover up this third component, that is the midpoint formula in 2 space. So to get 3 space, we just add that. The way I think about those, the way I finally got it memorized, was it's the average of the x's, right? When I average, I add them together and divide by how many they are. So average of the x's, average of the y's, average of the z's. That's how I have it memorized. It's just easier to put that in my head, less words, less things to spit off. Okay, so that is the distance formula. That is a sphere. We're going to write the standard equation of the sphere that has the points as endpoints of the diameter. So what we're talking about is these are actually 2 points on opposite ends of the side of the circle. We know that because they say endpoints of the diameter, diameter being the distance across my sphere. So I need to find 2 things here. I need the radius, and I also need the center point, right? That's what this x naught, y naught, z naught, or x sub 0, y sub 0, z sub 0. I keep saying naught, and that's, I actually don't know where that comes from. That was just taught by my older professors that I've had. I need to look that up. But if I say x naught, I am meaning x sub 0 like that. Okay, so I need the center point, because that's what this is. And then I need the radius. Okay, so center point is just going to be your midpoint. So let's go ahead and find that. So anytime I use a formula, I write it to help me memorize it. All right, sorry for the sloppy handwriting, but it's not worth. If you can read it, I think that's the important part, but keeping them level. Anyways, okay, so midpoint. Let's write it again. All right, average of the x is 5 plus 0 is 5 over 2. 4 plus negative 2 is 2 over 2 is 1. And then the z's, I get 0 over 2, which is 0. So there is my midpoint. That is my center of my sphere. I also need to find the radius. So I'm going to find the diameter, which is going to be the distance between those two, because they're endpoints. So that's the square root of 0 minus 5 squared plus 4 minus negative 2 squared plus negative 3 minus 3 squared. All right, let me slow down a bit to make sure my numbers are correct because I don't want to have an error in my video. Yeah, I think those are right. So we get 25 plus, that's going to be a 6, so that's 36. And then that's going to be another negative 6, 36. So I got 36 and 36 makes 72, 97. And that's in my radical. I'm going to leave it there since it's not a perfect square. That is a great diameter. So that tells me my radius, though, is the square root of 97 over 2. Now the formula for a sphere, I'm going to write this out. X minus x naught squared plus y minus y naught squared plus z minus z naught squared equals r squared. So I just plug everything in. X minus 5 over 2 squared plus y minus 1 squared plus z squared. I don't have to put minus 0. And then r squared is going to be 97 over 4. The square root goes away with the square, and then you still got a square 2 because it's not in the square root. There is my sphere. It's not pretty number-wise, but you get the point. We got to have the midpoint for the center. Diameter gives me all the way across. I cut it in half by divided by 2. Then I just plugged it into the sphere formula. What's going to end up happening this semester is you're going to see these formulas, and you're going to need to know that it's a sphere type thing. We're not going to do a whole lot of sketching, but there will be some. So get these formulas down.